I will explain about introduction, the background. As can be shown, water is Pelton wheel's primary sources of energy. The water velocity can be estimated from the feed's head and the flow rate can be calculated from the diameter of the jet. We will have the best speed rotation in this experiment since the bucket rotates at about half the speed of the plane. Next, for the problem statement, Pelton wheels are commonly found in areas where high water heads are usable all of the time owing to the solar energy driven water cycle. The power of the input water jets limits the amount of power that can be extracted in a Pelton wheel turbine. The input jet's efficiency can be calculated would use an equation. Next, for the objective, to determine the performance and the efficiency of Pelton wheel turbine at a different operation condition. Second, to understanding of the Pelton turbine's configuration and performance. Third, to design a complete measurement techniques of the fluid flow. Last but not least, for the scope, we are going to use Pelton turbine, hydraulic bench, data measurement, and data acquisition and tachometer to run through this experiment successfully.
Warahmatullahi wabarakatuh. My name is Shazani bin Muhammad Sunusi. My ID MA18283. So I'm the next presenter. Will present chapter 2 and chapter 3, which is theory and method and procedure. Chapter 2, theory. So this is about Pelton wheel turbine. The Pelton wheel turbine is a turbine which a tangential flow pulse for high water levels. It is a hydraulic turbine which is used primarily for electric power generation in the hydropower plant. The Pelton wheel turbine has four main components, where the dog, runner or bucket, case, and braking jet. The next is formula used in calculation of Pelton wheel turbine. The turbine input power formula is W in Q total P equals to PGHQ, where Q is the flow rate and P is the gauge at the inlet turbine. The next is the turbine output power. W out equals to FRW, where F is force times R radius and W is the velocity. So the next is the turbine efficiency, which is you can divide the turbine output power by the turbine input power. So the last formula is the turbine effectiveness, force time U. Okay, this is the legend. Pelton wheel, the jet speed, the derivative of power with respect to turbine speed, yields, and others. Okay, the next is chapter 3, method and procedure. Introduction. Chapter 3 describes in detail the method and procedure used in this Pelton wheel turbine experiment. In this hydraulic turbine, water jets tangentially affect the feed bucket. The way to produce torque is by driving or applying force on the Pelton wheel bucket as they rotate. Next is experiment equipment. The figure shows Pelton turbines equipment. Number 1, spring balance. Number 2, manometer. Number 3, nozzle adjustment. Number 4, nozzle itself. Number 5, Pelton wheel. And 6 is brake adjustment. And the next figure is hydraulic bench equipment, where number 1 is flow control valve, number 2 overflow, number 3 storage tank with pump, number 4 is valve, number 5 measuring tank level, number 6 is measuring tank. The last part is the experiment procedure. Step number 1, the connection is secure and no leakage is tightly connected. Number 2, release the emergency button. Step number 3, water will be added to the full tank of the experiment hydraulic bench for water supplies. Number 4, the hydraulic bench is activated and the valve is oriented vertically. Number 5, the speed controller controls or feeds the flow rate and the flow speed. Step number 6, shift the measurement level on the main switch and the tank level is measured after 60 seconds. Step number 7, Monitor and record collected data on the flow sensor, pressure sensor, and tachometer. The last step is the valve is turned horizontal, and after experimentation, the main switch is switched off. Okay, that's all from me. Thank you.
Hi, thank you. I will continue the presentation for the result. First, we look at the turbine characteristic curve for fully open at constant pressure 0.2 bar and constant flow rate 30.9 liter per minute. We can see the result obtained as shown in the slide. We move to the graph. As we can see here, the first graph is rotational speed against moment on the shaft. We can see as the rotational speed increase, the moment on shaft decrease. Next, we move to the second graph, which is rotational speed against power output. We can see the increasing of power output as the rotational speed increase. However, when the rotational speed reach 543 RPM, the power output start to decrease. And the third graph for rotational speed against efficiency, also the same, the efficiency increase as the rotational speed increase. However, when the RPM reach 543, the efficiency start to decrease. And next, we move to power curve. The result is for pressure at constant pressure at 0.2 bar, and the flow rate is 31.5 liter per minute. Here also we have the graph, the power comparison between the flow rate 30.9 liter per minute and flow rate of 31.5 liter per minute. We can see both of these graphs has not much different. The value is almost the same because the value of flow rate is not much different. So the pattern for the power output against rotational speed is almost the same for both graphs. And that's all for the result. And next we move to discussion that will present by Amirul. Thank you.
Thank you, Alif Lukman. My name is Muhammad Amir Akib bin Alias. My matrix number MA18278. We explain about the discussions of this experiment. From the turbine character curve, we could determine the Pelton wheel has some key qualities. The output of the Pelton wheel should improve as the rotating speed of the wheel increase, as previously indicated. This is due to increased wheel speed, which increases power output before lowering performance. For the graph rotation speeds against efficiency, the efficiencies of the Pelton wheel will decrease as the rotation speed RPM of the wheel increases. The reductions in efficiency is due to the lower volume of the water that can enter the buckets, since the absolute velocity of the bucket is greater than the absolute velocity of the water. Next, the graph of power curve. The maximum power output can be produced is 5.6 watt for the flow rate 13.9 liter per minute, with the rotation speed is around 474 up to 534 RPM. Besides that, maximum power output obtained for 18.75 liter per minute is 30.2 watt with the rotational speed at 470 RPM. The power output of 760 RPM rotational speed then comes out as 0. This is because the bucket speed is faster than the water jets. The turbine cannot longer reach the buckets of the turbine since it's travelling faster than the water jet, resulting in zero power generations. That's all for me. I will pass to Azmezaki.
Thank you, Amirul Hakim. As a conclusion, we have successfully done this experiment virtually based on the given video and the collected data. We have known how to design a complete measurement technique of the fluid flow. Other than that, we have completely determined the performance and the efficiency of the Pelton wheel turbine at the different condition operation. And from it, we can know the best performance of the turbine is from the average speed of the turbine. It is because the turbine with the load need a higher average speed compared to the turbine without load, because the turbine with the load will produce a higher power compared to the turbine without load. And lastly, it was generally a success as the result obtained were useful for the analysis of the properties of the machines. That's all from me. Thank you.